Lesson 10.15, finding x-intercepts algebraically. I want to talk real quick about if I have a graph and my function, let's say, does this. And I say, where's the x-intercept? That would be this point where the graph goes through the x-axis. What about that point as an ordered pair? It's going to have some kind of number for its x value, and then its y value is going to be 0. Every time, no matter where it's at on this x-axis, because it didn't go up or down. That's important for us to be able to get an x-intercept, is knowing that y is going to equal 0. So here are the steps. You're going to factor completely. You're going to cancel out any common factors, and then we're going to set y equal to 0 and solve for x, because in an x-intercept, the y is always 0. So let's try number 1. We need to first factor the bottom to see if we have any holes or any factors that cancel. And we're going to, because I see an x minus 8 plus x plus 4 is the correct factoring. So cancel, cancel. This needs to be a 1 in the numerator. So now write your new function, and I'm going to replace f of x and say, okay, it's just y. 1 over x plus 4. So now I'm going to replace y with 0. And then if I'm solving this, think of this as like a proportion where this 0 is over 1. You would cross multiply, or think about you're multiplying by x plus 4 on each side to get rid of this denominator. So you're going to have 0 times x plus 4 equals 1. 0 times anything is 0. 0 can never equal 1, so this will not have an x-intercept, which can happen. Could be that it has some kind of asymptote, which it does, because look, we have an x squared versus an x on top. So this is bottom heavy. This is where the x-axis would actually be an asymptote. So it's not going to touch ever. All right, number 2, factor. Take out a 2. That'd be times x minus 8. Slide and divide. So that would be 27 and 1. Divide by 3. So I get an x plus 9 and a 3x plus 1. Okay, so nothing cancels out. So then I'm going to set this as y. I'm going to make it 0 equal to 2 times x minus 8 over x plus 9 times 3x plus 1. So here's what I hope you learn, is that every time I'm going to cross multiply, so this denominator is always just going to be 0. So it's 0 equals 2 times x minus 8. So really I'm just setting the numerator. Put that as a star. Set numerator equal to 0 and solve. That's what it really is. Okay, so right here, all I got to do is think, okay, what number minus 8 would make 0 is 8. If you wanted it back from the beginning, that's fine. You would add 16, divide by 2, that also gets 8. Oh, once it is a coordinate point. Ooh. So that would mean it's at 8, 0. Number 3, I can take out a 3x. That would be times x minus 8. And on the bottom, take out a 5. That would be times x minus 8. Cancel out x minus 8. So my y equals 3x over 5 is my new simplified function. Y is going to be 0. So I'll have 0 equaling. I know that's going to make 5 times 0 be 0. So it's really just 0 equals 3x divided by 3. X is 0. So as an ordered pair, it would be 0, 0. At the origin is the intercept. And number 4, I can factor out a 3. That'd be x squared minus 15x plus 50. At the bottom, I'm going to take out an x, and that'd be times x minus 6. Okay. And then I have, that'd be negative 10 and negative 5. Nothing cancels. So this is 0. That makes the denominator disappear, and so it's equals 3 times x minus 10 times x minus 5. So this one actually gets 2 x-intercepts, 1 at 10 and 1 at 5. As ordered pairs, that would be 10, comma 0, and 5, comma 0.